Next presenter is Mrs. Eleanor Örnberg from Smoltek Innovation in Gothenburg, Sweden. She will focus on electrolyzers for hydrogen production, as we saw how important that was in the previous speech. Smoltek's nanotechnology has the potential to contribute to more efficient electrodes because the electrolyzers today are rather expensive, but the cost is coming down as we speak. Eleanor, I hand it over to you. Thank you.
Good morning and good afternoon, everyone. I'm sorry for these technical problems. I don't know really what happened. I am so happy to have been invited to speak at this conference. I think this topic is so extremely important for all of us. And I'm also happy to talk to you people here who share the ambition with us at Smoltek to make the world green and clean and fossil free. So my name is Eleanor Örnberg, and I am president at Smoltek Innovation, a nanotechnology company with headquarters in Gothenburg. I will show to you today, I will explain to you, our vision is that we want to develop what we say the world's most cost-effective electrolyzer cell material based on Smoltek's technology platform in cooperation with global market and technology leaders. And for you who doesn't know that, the electrolyzer is the equipment used to produce hydrogen. So first I will explain to you what carbon nanofibers is. That is what we at Smoltek do. Then I will explain and talk a little bit more about electrolyzers and how important they are to produce green hydrogen and how very large the market for green hydrogen and electrolyzers will be in the future. And then I will talk, finally, I will explain to you how we hope to be able to use our carbon nanofibers to develop a material, a cell material to use in electrolyzers, where we think that we can reduce very much of the expensive catalyst material that are used in the electrolyzers, and at the same time also make the electrolyzers much more compact, so they get smaller and cheaper to build and also to run. So this is Smoltek. We are a Swedish listed company solving advanced material engineering problems through nanotechnology. And nanotechnology really means that things are extremely, extremely small. That's what we are good at. So over the years, we have applied for over 100 patents, and we use our technology to solve difficult material engineering problems in several industry sectors. Today, I will talk about what we do in the energy area, but we also do a lot of things in the semiconductor industry. So the core competence and the patents of Smoltek is to grow carbon nanofibers. We call it grow because I mean, these carbon nanofibers, they are extremely small and thin structures that we create by more or less placing molecule by molecule on top of each other. So it then forms a fiber, and then we do a lot of these together. So we get this, you see this structure. And you see, we often say that it looks like grass. And the point is to get a very, very large surface. So if you look at the grass here, you see the little drops the drops of water. And you can imagine how many more drops of water we can have on a certain area when we have this grass than if it would have been a plain surface. And the same goes with our carbon nanofibers. So this is what we will do when it comes to electrolyzers. We will use this huge surface that we create, and we will put the catalyst particles here, which means that we will be able to, at the same area, have many more catalyst particles, which means that at the same area, we can create much more hydrogen. I will come back to this in a little while. But first, I'll say a few words about why we think that electrolyzer market for us is a good business opportunity, and why hydrogen will become so extremely important in making our world emission free. So there are three ways you use hydrogen for reducing the fossil fuel of CO2 emissions. The first is, of course, that you use it as fuel in fuel cells and in vehicles with fuel cells. And we know that most of the transports in the future will be electrified, but also that batteries are not always suitable. Specifically, if you are to go very long distances and you cannot charge. So, for instance, in airplanes or marine transports or long-haul automotive transports, you would rather use fuel cells than batteries, because you fill up the tank with hydrogen, and then the fuel cell use it to generate electricity in the electrified truck or airplane or ship. So simply, you reach much further with 300, as an example, 300 kilograms of hydrogen than with 300 kilograms of battery. So that is the first application, hydrogen for electrified transports. The second main area is in industry, just what Johnny Sjöström from SSAB just talked to us about. So in steel industry, they will use hydrogen instead of carbon in their future steel works. And this will be very big. This is so important. Globally, steel production stands for about 7% of all CO2 emissions. And when we talk about industry, let me also mention cement, for instance, which is about 5% of the CO2 emissions. And here we also see that hydrogen is being introduced as a substitute for fossil fuels. So this is huge, really huge. It will be a major contribution to the reduction of CO2. And for us who wants to, in a way, enter into the electrolyzer business, it's good to see that there will be so much hydrogen that is going to be needed here. The third thing, it says towns here in my picture, is that when we produce green electricity from water and wind and sunlight, the power supply very much depends on the weather. So therefore, we want to be able to store and sometimes also to transport the green electricity. And that we can do if we use the green electricity to produce hydrogen. So as an example, we have large solar cell parks out in the deserts, and they are being built right now, for instance, in China. Huge parks, but you need to have the energy where it is being consumed, and also when it is needed. And deserts are often far away, and also it's dark in the night. I mean, the sun doesn't shine. So the solar power, you use them to make hydrogen, and then you use it where and when it is needed by converting it back to electricity in a fuel cell again. For sure, you get some losses. This is not the most efficient way, but in many cases, this is a very practical solution when it comes to wind and solar power. So storage and transport of wind, water, and solar energy is the third main area for green hydrogen. And this in the future will be very big. So I move on to the next picture then. So here you see, I mean, obviously the hydrogen market is forecasted to be very large in the future. And some sources claim it will be 10 times larger already by 2030 and up to 100 times larger by 2050. These numbers are, of course, very uncertain, but in this picture here, you see some data collected by the Hydrogen Council this summer. And where these here you see announced and also started increasing capacity is being shown, which means that this chart shows real investments that already has been decided. For us at Smoltek, for our business case, it's only the green part that is interesting because this is where you use electrolyzers, where we then want to use our nanotechnology. The blue is you still use natural gas, but you put the emission back to the ground again. So they call it blue hydrogen instead of green hydrogen. Okay, that was it. So an electrolyzer, what is an electrolyzer and what do we at Smoltek believe we can do and why can we think we can come with new technology to make them much better, we hope. So an electrolyzer, it is the equipment that you use to make hydrogen from water. So water becomes green hydrogen. But to do that, of course, you need electricity. But only if you use green electricity, it's green hydrogen. And you wouldn't use anything else because it would be cheaper to make dirty hydrogen instead. So this seems good and it's clean and everything, but there is a big problem. And this is these are the catalysts. So to do this trick, this miracle, you need to use iridium and platinum. And price of iridium is 1.2 million SEK per kilo. And for platinum, it's 400,000 SEK for 1 kilogram. So the challenge here is really that the catalysts are so extremely expensive. So now I come to how do we then combine Smoltek's carbon nanofibers with electrolyzers. We want to use that. It's called catalyst support. I'll show you this. So let's start with this traditional solution for electrolyzers. You have a membrane and you see these little dots here. They represent the expensive iridium or platinum catalyst particles. So in the traditional solution, in this gray area, you see that most of them actually are hidden in this ink. I'm trying to point here. It's only the catalyst particles that are in touch with the green area here, the membrane, that are active, that actually do split the water into oxygen and hydrogen. All the others here, you see quite many, are actually more or less of no use or little use. So it's kind of waste of this extremely expensive material. I mark them here with black, so you understand what I mean here. So it's only the one in the surface, the one that are touching the membrane, that are active and that are used to produce hydrogen. The other ones, more or less, are of no use. So now comes the Smoltek solution, what we want to do. You remember I talked about carbon nanofibers. You know, I said we make these small fibers by placing molecule by molecule on top of each other. So we create a little fiber that consists of carbon. So it's a carbon nanofiber. And what we do here, we can actually place these catalyst particles outside these carbon nanofibers. The trick here, if you compare, you see all of them here are in orange color because all of them are in contact with the membrane. They are on the outside of the support here. They are not hidden inside the ink as in the traditional solution. So you see how much less of this expensive material we use. That is one thing. But then comes something else. You remember I also said that by using large number of fibers, you get a huge surface. So look, we can actually, at the same area in one cell, it's called cells, these things. In one cell, we can have so many more catalyst particles, which means that, and it's linearly dependent. So if you have 100 catalyst particles in one cell, you get 100 whatever hydrogen. So we do two things. First of all, no waste. And secondly, we make electrolyzer, we make it possible to make electrolyzer much more compact because we can squeeze in, we can load one cell with much more catalyst material. And this is really important because when it becomes smaller, we are talking about plants here, hydrogen plants. When it becomes smaller, it becomes cheaper to build and cheaper to operate. So let's look here then. Reducing hydrogen production cost. Here is a picture showing the cost elements that needs to be reduced in order to make green hydrogen competitive or attractive. And the most important thing to work on is actually the cost of the electrolyzer, to build it and to operate it. The two things.
No, you got 2 minutes left.
Yes, thanks. Where we believe we really have a good solution. So I will just finish by showing you where we are now with our electrolyzer development project. So on the picture, you see these carbon nanofibers. We have grown them on porous material. I don't think it means anything to most of you. But anyway, we have done a lot of tests that proves that we are where we want to be. And our next step is together with industrial partners and also with universities to start to build a few full cell demos with to find the best combination of the fiber geometry, what corrosion protection to use, what catalyst to use, what substrate to use, and so on. Once we have this, we will do durability tests of the most promising design. Then we are ready to start building prototypes and to try for real in real electrolyzers. So thank you so much for listening. And I think some of you might have really good knowledge in the areas of electrolyzers or the bits and pieces needed for the cell material that we are talking about here. So please feel free to contact me if you think that we could do something good and great together. So thank you very much for listening.
Thank you very much, Eleanor. Top-notch technology, and we will come back later with the questions that we get here from the panel. And thanks again.
Thank you.